Number 21, we're going to integrate. This one's kind of an interesting one. Just a little note here. I want you to recognize, as you look at this one, we can use our U-substitution here. So a little note, you could use U-substitution. It's going to be super easy. I'm going to use integration by parts just to demonstrate that we can find these indefinite integrals in more than one way. And what we're going to try to do is find out what works best for us. So I'm going to look at this one and I'm going to say U. Let's let U equal, and at this point now we're thinking logarithms all the time for U. We could let U equal the natural log of x quantity squared. Now the differential then, this one's pretty neat. We've got 2, the power rule here. 2 comes down, natural log of x to the 1 power times the derivative of what's inside, which is 1 over x, like this. So the differential du will be 2 natural log of x over x dx. Looks good. Now dv then is 1 over x dx. V is equal to the natural log of x. So this worked out pretty good, and we're getting better and better at this, so it's getting easier and easier. This is going to be natural log of x quantity squared times the natural log of x, which is the natural log of x times itself 3 times, like this. Minus, now let's see what happens when we do this. We've got a 2. I think I'm going to put that 2 right in front of the integral symbol. I think that'll look nice there. Natural log of x times natural log of x, which I will write the natural log of x squared over x dx, like this. And what the heck, right? What the heck? We end up with this question that we had before. Now I've got I've got it right here. It's actually this indefinite integral that we had. I have an indefinite integral, one of them on this side, negative 2 of them over here. So let's make a super clever move here. Let us add this negative 2 times this indefinite integral. Let's add that to both sides of the equation. So when you do that, you end up with, then, as I'm going to add two of these to both sides of the equation, and I'm going to have on this side right here 3 times the natural log of x squared over x dx equals, oh my goodness, this is really cool. Because our job the whole time was to find what this indefinite integral was. This is what our job is. I'm going to put it in red. This was our job. Your job, my job, our job is to find what that's equal to. Well, with a clever move here and dividing both sides by 3, we have found it. Look at that. We'll just add our little plus c on there and we got it. We got it made. Hooray. Who would have known, right? Integration by parts paid off here really well. Now, as I was talking right away, U-substitution would work. So I'm going to copy this one down again just to show a little notice here. Just a rerun of this problem. Our job is to figure out what this indefinite integral is, the antiderivatives. That's why we have the plus c here. So if we took the derivative of this, we'd get right back there, and you can check it out. It will work. It's pretty awesome. See, the 3 comes down, cancels out, natural log of x quantity squared times 1 over x, and we're there. But this time I'm going to do it with a little bit of U-substitution. I will look at this one. Here we used integration by parts. Here we're going to use let u equal, what should we let? Let's let it equal the natural log of x. This is a little U-substitution. Now with U-substitution, we have something happening like this. pretty good at U-substitution. So the derivative of U with respect to x is 1 over x. So the differential du is 1 over x dx, like this. That's looking great. I have 1 over x dx right here. So with a little substitution, this indefinite integral will change a little bit. It's going to look a little bit different. I've got u squared, and then the x dx is du, and this one, very easy for us to find the antiderivative of, is u cubed over 3, and then I'll just substitute back in what u was all along, natural log of x cubed over 3, tack on the little plus c, and we'll notice that well, we did it again, but with u substitution. Integration by parts or u substitution. Which one was easier? Well, you can decide. I think it was worth doing both because we found a real clever trick we could use if this ever happens to us again. We might notice, and that pays off.